All right, today we're going to talk about 18.15, and this is just combining some of the stuff we've been doing. So we're using derivatives from yesterday, and we're going to look at some cubic graphs. So let's use this particular equation. So y equals 2x cubed minus 3x squared plus 1. All right, so I'm going to find the turning points on the curve. Now, if we remember what a cubic graph looks like, a positive cubic graph looks like this, and you'll see that there are 2 points at which it turns. Now that's what we're finding, the stationary points. That's kind of what I was talking about yesterday, but then decided to stop talking about it because it was confusing people. So the first thing I'm going to do is find dy dx. I'm going to find the derivative of this. Same as yesterday, bring this down and multiply. 3 times 2 is 6x, and then this loses a power. Same here, 2 times 3 is 6, and then this loses a power, so it's just 1, and then nothing with this because it's got no letter. So this is my differentiated equation. So what I'm going to do is solve this as if it's a quadratic. You can use the quadratic formula. Remember, that always works, but I think it's easier just to factorize it. So when we're factoring, remember, we make it equal 0, and then the first thing we look for is common factors. They both can be divided by 6, and they both can be divided by x. So if I divide this by 6x, I'm left with 1x. If I divide this by 6x, I'm left with -1. Now, for this statement to be true, anything times 0 is 0. So either this bit equals 0 or this bit equals 0. So then x equals, well, this bit has to be 0. 6 times 0 is 0. And this bit has to be 1 because 1 minus 1 is 0. So these are the 2 points on the x coordinate line where there are turning points. So if I was going to draw it, there's a turning point somewhere where x is 0 and somewhere where x is 1. I just don't know the y coordinate. So what I'm going to do is use these values, put them back into my original function, and discover where they might be. So the first thing I'm going to do is say y equals, and I'm going to substitute in 0 instead of x. See what I get. That all equals 1, right? This is 0 minus 0 plus 1. Then I'm going to do it as if it's a 1 because that was my other solution. Cubed minus 3 times 1 squared plus 1 equals 2 minus 3 plus 1, which is 0. So that means the coordinate for this one here is 0, 1, right? 0 and 1. And the coordinate for the other one is 1, 0. So if I was going to draw it, I know that 0, 1 and 1, 0 are my 2 turning points. And I know that this is the general shape of a cubic. So if you had to draw it, which you don't always have to do, so read the question carefully, I'm going to do this and then turn when I get to this dot, and then turn again when I get to this dot. And it doesn't matter about anything else. You're just approximating. So don't worry about anything except the turning points and whether it's positive in this direction or if it was negative, it would do that. But those points wouldn't make sense, obviously. So then we're asked to find, is it a maximum or a minimum turning point? Well, this is a maximum, right? Because it gets to the top and then it goes back down. This one is a minimum because it goes down and comes back up. The minimum part of the graph, the maximum part of the graph, right? Min. Man, I should have turned my messages off. So that means this point here, 0, 1, that's a maximum turning point. This one, 1, 0 is a minimum turning point. All right. That's basically what you have to do today. So if you're going to find the turning points, the first thing you want to do is, if it's not already expanded or looking like a normal equation, do that first, get rid of any brackets, all of that sort of stuff, then differentiate, then try and solve it like it's a quadratic or a linear equation if it's just that simple. If you can't figure out how to do that, remember, you can always use the quadratic formula. You know what, I'm going to do this as the quadratic formula just to prove a point. Okay, I'm going to save this and clear it. So the formula was, oh, this is what we ended up with, right? 6x. So remember, our quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. So if I wanted to do this, I would just put in these values. Negative b is positive 6 because this bit's b, plus or minus the square root of b squared minus 4 times a times c is 0, right? Because there's nothing over here. That's 0. All over 2a, 2 times 6. So then I would work this out. So this is 6 plus or minus the square root of, well, this is just 36, isn't it? Because that's 36 and anything times 0 is 0. So this bit just disappears. All over 12. So look at this. This is 6 plus 6 over 12, which is 1, right? 6 plus 6 is 12. Over 12 is 1. And it's 6 minus 6 over 12, which is 0. See how those are the answers that we got by factorizing. But if you couldn't have done that and you forgot how, the quadratic formula will still give you the 2 answers that you're looking for. It always works. Okay, please drop me an email if you need some help. Otherwise, good luck with 18.15.